Morning everyone. Today we are going to discuss about full wave rectifier. This topic comes into the unit 4 semiconductor diodes and their application. The subject name is circuit analysis and devices. So come let's get into the topic. So already we have discussed about the half wave rectifier. So either half wave rectifier or the full wave rectifier, both is the applications of the PN junction diode only. The number of PN junction used in the circuit is different. That is the only difference between full wave rectifier and the half wave rectifier. So according to the full wave rectifier circuit, it is used for producing an output voltage or output current which is purely DC. The main advantage of full wave rectifier over half wave rectifier is that the average output voltage is higher in the full wave rectifier. There is less ripple produced in full wave rectifier when compared to the half wave rectifier. So working of full wave rectifier, the full wave rectifier utilizes both halves of each AC input, whereas in the half wave rectifier only one half of the AC input is utilized, where other half, that's negative half, will not be used. When the PN junction is forward biased, the diode offers low resistance, and when it is reverse biased, it gives the high resistance. This circuit is designed in such a manner that in the first half cycle, if the diode is forward biased, and in the second half cycle, it is reverse biased, and so on. So the input here, this is the circuit diagram of the full wave rectifier circuit. Here, the AC input is given to the transformer circuit, which has two diodes, whereas the half wave rectifier will have only one diode and one load resistor. So the transformer, which has step down transformer, the primary and secondary winding will be there. So here AC input voltage full cycle, there is a positive and negative cycle is there, which is given to the transformer. So the circuit which gives the output will be what both the half cycle will be coming out of the output circuit. It's a DC output voltage. Where in the where in the half wave rectifier circuit only one half cycle will be coming out of the output section. So the rectifier efficiency. Rectifier efficiency is used as a parameter to determine the efficiency of the rectifier to convert AC into DC. It is the ratio of DC output power to the AC input power. The rectifier efficiency of the full wave rectifier is 81.2%. But in the case of half wave rectifier, it is around 40% because it's a half wave, but this is the full wave. So full wave 81 percentage around, and full half wave rectifier will have only 40%. That's the difference. That's the rectifier efficiency difference between these two rectifiers. And type of full wave rectifier, we have two types, major types. That is a two diode full wave rectifier circuit requires a center tapped transformer and used in a vacuum tubes. And another type is bridge rectifier, does not require a center tapped transformer and is used along with the transformers for efficient usage. So these are all the two types of full wave rectifier. So the bridge rectifier is given over here. The AC input is there, transformer, and the four diodes which is used in the bridge rectifier, that four diodes which forms the bridge like a connection. So that's why it is called a bridge rectifier. And finally we will be getting the pulsating DC output signal. And this one is nothing but a two diode full wave rectifier circuit that we have seen in the previous slide. So there are input 1 and input 2. So output will be, we are getting at the output section. So these are the two major classification of full wave rectifiers. The advantages, when you look at the advantages of the full wave rectifier, the rectifier efficiency of the full wave rectifier is high, the power loss is very low, number of ripples generated are less. So these are the advantages, and the disadvantages, it is very expensive. So this is the major disadvantages. And when you coming for the applications of the full wave rectifier, the following are the uses of the full wave rectifier. The full wave rectifier are used for supplying polarized voltage in welding and for this bridge rectifiers as used. And full wave rectifiers are used for detecting the amplitude of the modulated radio signals. So here this, yeah, so the graphical representation which can able to understand still in a better manner how the AC is converted to DC. So here the AC black and red color is indicated by the color changes. So in the each cycle, so when positive cycle and the negative cycle comes into the picture, how it converts as a DC. That is given over here. And one more example is here. This is also one of the graphical representation. In input is given. So the bridge circuit, the bridge rectifier, which converts AC into DC, pulsating DC. In the both half cycles are coming out of the output. Thank you.